Hi everyone, so in today's video we will be discussing area of curves in polar coordinate system. So area in polar comes in this equation. We have area is equal to 1/2 integral of r squared d theta, and the limits will be from theta 1 to theta 2. There's three ways in testing for symmetry. Testing the polar curves if it is symmetric to the x-axis or to the y-axis. First is if the equation does not change when theta is replaced by negative theta, the polar curve is said to be symmetric with respect to x-axis. And when r is replaced by negative r and the equation does not change, meaning to say it is symmetric with with respect to the origin. And for the third case, when theta is replaced by negative theta and r by negative r, and the equation does not change, meaning to say it is symmetric with respect to y-axis. So you have here, find the area of the curve r is equal to 2a cos theta. So before we proceed with solving the area of our curve, we also need to test first in which axis it is symmetric, or where is the polar curve where we expect our curve to be symmetric. Would it be in x-axis or in y-axis? So in this case, we have to test if theta will be replaced by negative theta, it will result, if it results to the same equation, then meaning to say it is symmetric with respect to x-axis. So r is equal to 2a cos negative theta. And as we know from the property of our trigonometric function, if cosine has an angle of negative, it will still result to positive. So meaning to say, that being said, it is still equal to our original equation. Meaning to say, our curve is symmetric with respect to x-axis or the polar axis. Now, if we also try to change our r by negative r, negative r is equal to 2a cos theta. As you can see, this will be different now since our r is negative, meaning to say this is not symmetric with respect to our axis. And if we replace negative theta and negative r, let's say negative r is equal to 2a cos of negative theta, it will still result to negative r is equal to 2a cos theta, meaning to say it is not symmetric with respect to our y-axis. So we will be expecting that our polar curve is symmetric to x-axis or the polar axis. So in solving this kind of problem, we still need to follow the same process with in solving areas in plane areas. So in this case, meaning to say, we also need to find substitute some values for our r and theta so that we can sketch it in our graph. Now, meaning to say, we can substitute any values to our theta and our r. But let's start with angle 0 and 2a cos theta of 0, that is equivalent to 1, meaning to say this is 2a. If we substitute 30 degrees to our theta, our r is square root of 3a. If we substitute 60, we have a. Then we substitute 90, we have 0. Then we also have 120 and negative a. So basically, you can just substitute values or the angles here for our theta, and then let's see for the result of our r. Now, the moment we will stop at the moment we already enclose our polar curve in our sketch. So meaning to say, you can just continue so long as our curve is not yet enclosed. So in this case, we try to graph this one first in our Cartesian plane. But now, it will be different because we are already dealing with the angles or the theta. Meaning to say, we'll not deal with rectangular Cartesian plane, but we also we'll need to change this one into a circular Cartesian plane. And to say this is our angle 0, this is 30, this is 60, and so on and so forth. So I'll try to make this as clear as possible. So that's it. Now this will be our A. This is 2A. This is A. This is also 2A. Now 0 and 2A, it's somewhere here. 30 and square root of 3A, that is also equivalent to square root of 3. I think that's around 1.73. So that's here. And then we have A. So it's somewhere here. 60 and A, that is here. 90, 0, here. This is our 90, our 120, 150, this is 180. So 120 and negative A. So when you say that it's negative, instead of going here, this is the positive A, it will go to the opposite direction, meaning to say it will go here, the negative A, since it is negative A. Now, I think we haven't closed our area yet. Now, we'll continue with 150. Because if you try to create a polar curve from this one, this is just until here. Meaning to say it is still open here. So, meaning to say we need to continue with 150. 150 is negative square root of 3A. So, meaning to say this is 150 and it's negative. Now, it will go to the opposite direction. So, it's here. So, if you try to close this one, that's still there. Now, it's not, it's still open here. So, we need to continue. If it's 180 degrees, that is negative 2A. This is our 180. And this is the 2A, the positive 2A. Now, it says that it's negative. So, meaning to say we have to go from here. Now, this is our 2A, right? So, meaning to say we already closed our polar curve. Now, as we know, our area is equivalent, the equation of our area is equivalent to 1/2 of theta 1 to theta 2 r squared d theta. And we know that our r is 2a cos theta. Now, how should we determine the limits, the lower and upper limits from our graph? So, to determine our area, our limits from our graph, we need to find, so to find our limits, we have to look at our graph. So as you can see here, the 2 points that we are at peak, or the maximum and the maximum and the minimum point is pointing at 0 degrees and the 90 degrees. So meaning to say, since we started at 0, and then it does not increase anymore, the points does not increase anymore, it decreases until our 90, and then from our 90 it does not increase anymore to any points here, meaning to say our lower limit is already our 0, and our limits will be our 90. But we have to convert our angle to a radian, and we know from trigonometry that in order for us to convert our angle to a radian, we have 90 times pi over 180. So that is equivalent to pi over 2. So meaning to say our upper limit is pi over 2, and then we have our r squared d theta. And you also have to remember that this area is only for one quadrant only, since our curve touches 2 quadrants, meaning to say we have to multiply this one by 2 as well. That being said, we have the equation of our area is equal to 2, since we touch just 2 quadrants, and then 1/2. the limits, the r squared. Since our r is equivalent to 2a cos theta, then we have the square d theta. Now, 2 times 1/2, that is just 1, so you can have this as 1, pi over 2, and then 2a squared, that is 4a squared, cos squared theta d theta. We know that 4a squared is constant, so we can put that outside our integral symbol. So we have 0 to pi over 2, and then we have the cos squared theta d theta. And as we know from its identities, cos squared theta is equivalent to 1/2 4a squared, and that's 0 pi over 2. Cos squared theta is equivalent also to 1/2 times 1 plus cos 2 theta d theta. Now, afterwards, we can separate this one. We have 4a squared, then integral of 0 to pi over 2, 1/2 d theta plus 0 to pi over 2, 1/2 cos 2 theta d theta. So integrating this one, we have 4a squared, and then we have 1/2 theta plus this one, cos 2 theta, our u here is 2 theta. U is equal to 2 theta. Du is equal to du over 2 is equal to d theta. So meaning to say 1/2 times 1/2, we have 1/4. Integral of our cosine is sine, positive sine, 2 theta. Then we have our limits from 0 to pi over 2. So distributing our 4a squared, we have 4 times 1/2, that is 2a squared theta. 4 times 1/4, that is 1. So meaning to say we have a squared sine 2 theta. Now substituting our limits, we have 2a squared times our limit, upper limit pi over 2, plus a squared sine 2 times pi over 2 minus, we have, if you substitute this one to our equation, this will result to 0. So that being said, that is 0. Now calculating this one, we have, this is pi a squared, or a squared pi, since we can cancel 2 here. Then for this one, since this is sine 2 pi over 2 is equivalent to 0 times a squared, meaning to say that is 0. So meaning to say our area of the polar curve is equivalent to a squared pi square units. So this is now our final answer. So we have here, find the area of the inner loop of the curve r is equal to a times 1 plus 2 cos theta. So before we proceed with the integration or finding our area, we need to plot first our sketch, or we need to sketch first our graph, and then before we do that, we need to find or substitute values to our theta and our r. So for example, our theta and our r, if we have 0 here, our r is equivalent to 3a. Just to substitute that one in this equation, and if we have our theta as our 30, we have 2.73a. 60 is equal to 2a for our r. 90, that is equivalent to a. And 120, that is equivalent to 0. So Let's try to plot this one first in our Cartesian plane or on our polar plane. So let's have so 0 and this is A, 2A, this is 3A, A, 2A, and 3A. This is our 0, 30, 60, and so on. So plotting the points to our graph, we have 0 and 3A. That is here. This is A, this is 2A, and 3A. So that's somewhere here. And then 30 and 2.73, so that's somewhere here. 60 and 2A, that's around here. 90 and A, so this is our A, 2A, 3A. So this is our 90, so meaning to say our A is here. And then 120 and 0, that's 0 here. Then as you know, we haven't closed any polar curves yet, so we need to continue with our substitution. So we have 150, that is equivalent to negative 0.73 A. Then we have 180, that is equivalent to negative A. And for 210, we have negative 0.73 A. And then for 240 degrees, we have equivalent to 0. So let's try to continue. So we end with 120 and 0, which is here. Then we'll try to graph 150 and 0.73, negative 0.73. This is 120, this is 150, and it says negative, so meaning to say it's going to the opposite direction. So 0.73 is somewhere here before our A. And then for 180 and negative A, this is our 180, this is the positive A, meaning to say this is our negative A, so it's somewhere here. 210 and negative 0.73, that's somewhere here, so it's very small. And 240, this one, and 0, that is here. So meaning to say, if we try to connect our points here, it is from here going down, and then the inner loop, there's an inner loop which is this one. Then but we need to enclose the outer loop first, so meaning to say this substitution will still also continue. So if we try to check this one using symmetric, or try to test the symmetry of this one, you'll know that it is symmetric in x-axis. Meaning to say, that being said, you can just continue plotting this one since it's said to be symmetric with x. Meaning to say, the points here are just symmetric but it in negative sign. So meaning to say, this is also equivalent to this one. But the only area that we are looking for is the area inside this inner loop, which is this one. Now the next process is to find the limits of our integration. So the limits that we need to find is just the limits of the inner loop. So from here, we know that it started from 0, which is 120. The angle of this one is 120. So meaning to say, if we transform 120 into radian, we have pi over 180. This is equivalent to 2/3 pi. So meaning to say, this is now our lower limits, and it ranges to a maximum point, which is this point. So as you can see, these are the lower point and this is the maximum point. Now this point has an angle of 180. As you know, this is 180 and negative a. So meaning to say, if we convert 180 to the radian, that is equivalent to pi. So meaning to say, this is now our lower limits and this is our upper limit. So now we have the equation of our area as 2 times 1/2 from 2/3 pi to pi, and then we have our value of r squared d theta. 2 here is, again, since it touched two quadrants for our plane or in our polar curves, so meaning to say this can also be equivalent to 1. Then we have now 2/3 pi to pi, and then for this one, this is also equivalent to a squared times 1 plus 2 cos theta squared d theta. So for this one, a squared is constant, so we can move that outside our symbol. So we have 2 pi over 3 pi. And then for this one, since this is a square of a binomial, so we need to expand this one. So we have 1 plus 4 cos theta plus 4 cos squared theta. Then we have the d theta. Now we can already integrate this separately. So we have a squared integral of 2/3 pi to pi d theta plus 4 2/3 pi to pi cos theta d theta plus 4 integral of 2/3 pi to pi cos squared theta d theta. Now, integrating this one, we have a squared theta plus integral of cosine is positive sign, so we have 4 sine theta. And for this one, as we know, cos integral of 2/3 pi to pi cos squared theta, that is also equivalent to 1/2 times 1 plus cosine 2 theta d theta. Now integrating this part, we have a squared theta plus 4 sine theta plus 4 times 1/2, that is just 2 integral of d theta, and of course the limits here. And then we have also 4 integral of cosine 2 theta d theta. No, I'm sorry, 4 times 1/2, so we have 2. So we have a squared theta plus 4 sine theta plus this one, integral of this one is 2 theta plus the integral of this one is sine 2 theta, since 2 times 1/2, that is equivalent to 1. And then we have our limits from 2/3 pi to pi. So theta plus 2 theta, we can just write that one as 3 theta plus 4 sine theta plus sine 2 theta from 2/3 pi to pi. Now substituting our limits, we have 3 pi plus 4 sine pi plus sine 2 pi minus we have 3 times 2/3 pi, so cancel this one, plus 4 sine 2/3 pi plus sine 2 times 2/3 pi. So if you try to calculate this one, we have a squared. This is 3 pi plus 0. Sine pi is 0 times 4, 0. Sine 2 pi, that is also 0. minus for this one, we have 2 pi plus 2 square root of 3 minus this one, square root of 3 over 2. So for this one, this is equivalent 3 pi minus 8.88, that is equivalent to 0.54 times our a squared here. So we have 0.54 a squared square units. So this is now our final answer. Thank you so much for watching the video, and I hope you learned something. Please don't forget to like our video and see you in the next video.